Well, hello, sixth grade. Hope you're doing well. Feeling exceptionally accomplished for having accomplished lesson 100, where we're going to keep moving. We're going to keep moving strong. Today we're going to be looking at complex shapes, so L101. Excuse me. Basically, a complex shape, as you could probably tell by looking at the picture here, which you should be drawing up and obviously noting all the things that I've noted, is a combination of shapes. It's not just a standard polygon like a rectangle or a non-polygon like a circle. It's kind of a combo of maybe a rectangle and a rectangle, or a triangle and a rectangle, and things like that. That's what we call complex shapes. And we're going to focus on three things in this lesson. One is perimeter, the other is area, and then we're going to look a little bit at angle measures. So hopefully at this point you've drawn that out. If I were to find perimeter of this shape, if that's what they were looking for, one is we could almost go back to our really younger sort of way of thinking about perimeter, which is just adding up all the sides. There is an issue, though, because I do have this side length, and I have this side length, and I've got that side length, and I do have that side length. However, you notice that both the A and the B, have not given me that information. Am I capable of finding that information? I am. I just have to look at what they've given me, kind of look at the data, and then make conclusions. So if we're going to focus on this A, if you notice that the A is this kind of up and down line segment, and then what I can do is connect the concepts of the like this idea. So notice how if I drew this up like that, that would be the same distance as A, right? Exact same distance, that little dotted line segment there. So if I consider that there's a 6 centimeters over here, and there's a 4 centimeters over here, well, it would be 4 plus what would give me that 6? And hopefully you could go, oh, well, wouldn't that have to be 2 centimeters? And yes, it would. We can do the same with the B. Notice how that's a horizontal kind of line segment. And if I look at the 3 centimeters and the 7 centimeters, I realize it would be like basically B plus 3 would equal the 7, right? So what would that B have to be? And you'd be right to say that it would have to be 4 centimeters. So I'm going to show you something that you can do with perimeter, although you have to do it right or it's going to be mathematically wrong. Usually we've been trained, by me, of course, to write out everything using those units. And thank you so much for those of you who are doing it. There is, when I'm doing perimeter, something I can do that's slightly different. So I'm going to put P equals. I'm going to open up, I'm going to start at that 7 centimeters and go in a counterclockwise direction. But I'm going to open up a set of parentheses here. And I'm just going to put my 7 plus my, what's next? My 6 plus my, I'm just going to go around the bend there. My 3, and you might be like, what about the units? Don't worry, I'm going to show you. And then I'll go plus 2, and then I got a plus 4, and I have one more plus 4. It's always good to kind of count up and 1, 2, 3, 4, 5, 6, and I've got 1, 2, 3, 4, 5, 6 numbers. Now, in order to keep this mathematically sound and concerning our units of measurement, I'm going to close that set of parentheses, and I'm going to label that with centimeters. And that's an okay way to show it. We can't always do it, and it really only kind of comes up perimeter. Then, obviously, we'll say, okay, so P is equal to, and then we're just going to add up. 7 plus 6, 13, 16, 18, 22, 26. P equals 26 centimeters. And I can box that up. Yeah, not so bad. Hey, let's keep going. Let's try another. Please draw this up. It's kind of like a weird looking L. And go ahead and label. And again, we're going to be asked to do perimeter here. That's our interest. Notice, just like before, they haven't given us the M and the N. So if I think about, let's say, the M, I know that the M is kind of made up of this 4 inches, and that's 10 inches. And basically it'd be like 4 inches plus M is equal to 10 inches, right? That would be the same length. So I can conclude out there that the M must be 6 inches, right? Hopefully you can do that same conclusion. When I go to think about the N, similarly, I'm going to use the N. I'm going to think about this 8 inches and this 2 inches. And basically, 8 inches minus 2 inches would give me N. Therefore, that must be 6 inches as well. And then like before, we can do that little parentheses thing. So I'm going to let's start at the 10, and we'll go in a counterclockwise direction, might as well. So we'll go 10 plus 2 plus 6 plus 6 plus 4 plus 8. Then I close the parentheses, and then I put my unit. And that would mathematically work, right? And again, a quick count, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, yeah, it looks all good to me. Then I go ahead and do my adding. So I got 10 plus 2, 12, 18, 24, 28, 36 inches. Boom. Not so bad, right? However, I want you to think about this. Is it necessary to find these units out when finding perimeter? And I think you'd probably conclude, well, yeah, of course. If you don't find those out, then how could you do it? Well, check this out. This doesn't always work, but I do want you to see this because sometimes you might go this route. So if I was to take this n and like push it that way, just that length, and push it to say there, right? I haven't increased the length. I just pushed it out to the right a little bit. And let's say I did that with the m and I pushed it up to form a whole rectangle. Would that now be a rectangle? See the whole thing? Could I use my formula? P equals 2L plus 2W. Well, let's try. Okay, so we'll say that the length, the L, is to 10 inches. So I'll say P equals 2 times 10 inches. And then we'll claim our width to be the 8 inches. 2 times 8 inches. Close that up. And let's figure this out. So 2 times 10 inches is clearly 20 inches. 2 times 8 inches, clearly 16 inches. And then when I bring it together, hey, it's 36 inches. It's the same. And that works. But I'll say it works sometimes I can do this. Sometimes no, though. So not every complex shape will allow this. But that kind of one that we originally started with could. However, you'd have to caution yourself. Let's imagine I had this kind of shape, which is considered a complex shape. Could I take that portion and push it up to there? I could. But the problem was if I did that, I would be discounting the side lengths of that guy and that guy. So that little method of us using a formula wouldn't work. Yeah, just wanted to share that with you. Hey, let's move on to these. So here, kind of similar shapes. However, one of them ends in a roundy thing, kind of like a basketball court, like where you shoot a free throw from. And the other ends in a more triangular sort of things. On the right side, they give me a little bit more information. So they tell me that this whole thing on the bottom is 13 centimeters. And that this kind of part of that, do you see that triangle in there, is 5 centimeters. And what if they just wanted to know, hey, what's the greater perimeter? Now, we can't just guess. Obviously, you have to show me some math to prove it. But for the shape on the right, I definitely have, I've got my 4 centimeters and my 10 and my 5 and my 13. So I can figure out the perimeter of that right now. P equals, let's open up those parentheses, 4 plus 10 plus 5 plus 13. And then we know, okay, so that's 14, 19, 20, 32 centimeters. So done with that one. Now we go over here. I've definitely got my 4. I've got that would be 10. We know that. And that would be, see that rectangle there? So it's kind of like the same as the other one, right? Where I had that same sort of rectangle. So we really just have to find out about this thing. And what is that thing? Good. There's something called a semicircle. That's the MI circle, right? And to find out the length of that, we want to be considering something very important called circumference, right? So I know the 4 is the whole thing. So if I was to figure out this portion, boom, 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 what would that be? Well, of course, it would be half of that 4. So 2 centimeters will represent my radius of the semicircle. And then I got to bring in my circumference concept. So we know that C is equal to 2 pi r, but be careful here because I don't want a whole circle. I want half of a circle, a semicircle. So I could actually divide that. What that is going to be 2 pi r divided by 2. And then we know we could cancel that out. So what I'm just figuring out for the semicircle is pi r, basically. So I'm going to say that the circumference of that semicircle would be approximately, and we'll toss in our 3.14 right now. And then our radius we know is 2 centimeters. And I should be able to do that mentally. So C is approximately 6 and 2800 centimeters. Now remember, you're not done, obviously, because remember we've got this side length and that side length. We know that side length would be 10 centimeters. That's already labeled at 4. There's another 10. And I could do my thing. P is approximately equal to, open parentheses. I'll go with the 10 plus the 4 plus the 10. And then don't forget this guy, plus the 6 and 2800ths. Close that up, put some centimeters on it, and then just do some nice adding. So 10 plus 4 is 14, 24, 30, and 2800ths centimeters. So which one has the greater perimeter? Well, that guy. This guy, right? Greater perimeter. All right. Dos más. Draw this up. And this might look familiar, but we're going to do something different for this one. We're actually going to do area. And so area is very important, and there'd probably never be a time that you wouldn't have to find out what that A and B are, or at least one of them. So let's do the A quickly first. We know that A is kind of a part of this 4 centimeters and the 6 centimeters. Therefore, I can conclude that A is 2 centimeters. The B is obviously part of this 7 and 3, so it'd be 7 minus 3, basically, so that's going to be 4 centimeters. And then, in order to find area of this complex shape, one thing you can do is called composite, right? Composite area. And I'm going to break this shape up right here. Boom, boom, boom. And when I do that, I form 2 different shapes. We'll call this one shape A and this one shape B. And when I think about that, I'd say, okay, so the area is going to be equal to shape A plus shape B, right? So what is shape A? Well, look at it. What is it? It's got these dimensions, right? Boom, boom, boom. So that 4 and that 4. So it's a square. So I'd say area is equal to S squared, because that's our formula for area of a square. And then over here, I've got my rectangle, shape B. So that's this thing, right? So I'm going to use that 3 and that 6. And I know the formula would be LW. And then I just plug in. So A is equal to, remember our side length on our square is 4 centimeters. So I'll say 4 centimeters squared. And then plus, and then I'll say 3 and that 6. So we'll go 3 centimeters times 6 centimeters. And then we'll do our math. So 4 centimeters squared is 16 centimeters squared. 3 centimeters times 6 centimeters is 18, and then clearly centimeters squared. And then I do a little bit of adding. A equals 34 centimeters squared. Hey, Earl Campbell. Boom. Yeah, not so bad. Now you might go, oh, I was thinking that we were going to break it up, but I was going to break it up in a different place. Yeah, you just want to break it up in as few shapes as possible, 2 for this one. But you might have seen that break happen in a different place, and that's okay too. Just try and not make it too complex on yourself. Hey, last one. This one we're going to talk about angle measures, so go ahead and draw up what you see. I have a kind of a rectangle-y triangle thing. And then you see this exterior angle that they've given us at 130. And obviously they want to know, well, what's the measure of angle A? What's the measure of angle B? Well, we can do this because, look, if we see this portion as kind of a straight line or a straight angle, we know that straight angles are 180 degrees. So I could say that angle A plus 130 degrees would form a straight angle, which is clearly 180 degrees. Then remember, you don't have to show me all the subtracting 130 on both sides. We can kindergarten box our measurement stuff like this. So that would mean that A would have to be, 50 degrees. Boom, done with that one. Okay, let's go on to the B. So we know the B is part of this triangle. And we know that the sum of the angles in the triangle is always 180. So we know our A is already 50. So we'll say 50 degrees. Then we've got our B. And then, we know this one is a right angle, right? So that's 90 degrees. And the sum, as we said, of interior angles of a triangle is always 180. Do a little simplification here. 50 plus 90 is 140 degrees. Plus B equals 180. That you don't have to algebraically note here. You can kindergarten box and state that B is equal to 40 degrees. Boom! Hey, that was a lot. You guys did great. I'm very impressed, as I already told you. And we'll continue to feel that way. This is Monday, however, we did an investigation. So you're doing the real deal Holyfield, homework 101. We are testing this week. Hope you're doing well. You can reach out to me anytime. Bye-bye.